Welcome to this workshop in collaboration with iBECOME and Autodan. My name is Mark Power from Irish Manufacturing Research. I am involved in the communications aspect of the iBECOME project. So welcome to our EU Green Week partner event, which will focus on intelligent buildings supporting energy transition and the EU Green Deal. So just so everyone gets an idea of why we're here, as I mentioned, this is the EU Green Week. What is EU Green Week? Well, basically, it's an annual opportunity to debate European environmental policy with policymakers, leading environmentals and stakeholders from European and from Europe and beyond. So this year's edition focused on the EU Green Deal, the EU sustainable and transformative growth strategy for resource efficient and climate neutral Europe by 2050. So we're just one of many events which are taking place this week. You will see others on this website link here that I can share. So if you just Google EU Green Week 2022, you'll be brought to a website and you'll see the whole host of events that are taking place, both virtual and physical, around Europe this week. So here's the agenda from today. We have a variety of speakers from both projects, and we also have a guest speaker. So to begin the webinar, we will have Demetrius Intimus from IES, who is project coordinator of the iBECOME project. Following on this will be Georgina Spiglantani from Rena C, who will go through the Autodan project overview. Next will be our guest speaker for today, and we're delighted to have Eduardo Suarez Antunes, the policy officer at DG Ener, to look at the EU energy policy perspective, focusing on energy and efficiency and ROI funding. Following on from this, we will have Simone Buffa from Civiesco. So Simone has the pleasure of working across both projects. He's involved in iBECOME and both Autodan, and he will discuss the expectation strategies and replication potential for both projects. Following on for this, we will back with Georgia, who will look at the Autodan policy contribution to the EU Green Deal. And this will be followed by Pierre, who will look at a similar topic, but focus this time on the iBECOME policy contribution to the EU Green Deal. And this will be followed by a Q&A chat. So I would ask everybody to make this workshop as engaging as possible. There is a chat function and a Q&A function at the bottom of your screens. Feel free to add questions here, and at the end of the workshop, we will go through your questions, and you can ask each member a certain question on their chosen topic, or maybe a general question on each project or the EU Green Week or the Green Deal. So whatever you feel like, we will hopefully make this an engaging presentation for you, and we look forward to hearing from you at the end. So without further ado, I think it's time to get the speakers to start. So first off will be Demetrius, who will speak about the iBECOME project.
Thank you, Mark, and thanks everyone for joining. So good morning, everyone. My name is Demetrius Timos. I'm working with IES, and I'm here to give you an overview of iBECOME project, which is a collaborative project composed of 10 partners from 4 countries in the EU and funded by the Horizon 2020 framework. So now what iBECOME wants to do is to demonstrate a combination of novel technologies for reducing bills in a building or facility through energy savings and demand response, while improving the occupants' well-being and optimizing comfort by leveraging IoT, data analytics, and more efficient control of a building, while also enabling additional services such as EV charging optimization. So why we bother, why we do all this is we spend 90% of our time inside the building, which is an environment we spend most of our lives, the indoor environment, which is many times there is a poor comfort and well-being inside the buildings, and the EU building stock is getting older and older. More than 40% of energy and 36% of emissions are attributed to buildings. And as I said before, 75% of our existing building stock is energy inefficient. We see around us an IoT and big data evolution, so we want to leverage it. And at the moment, there is a lack of intelligence and interconnectivity in existing buildings. So now we bring over the virtual BMS, as we call it, virtual building management system in iBECOME, which we hopefully be a software as a service, where we start from the data inside the building, where on-site meters and sensors will be feeding real-time information about the building status and performance in the intelligence part of the iBECOME building management system, where the data processing, the forecasting will take place using the weather data, using the IoT and physics-based simulations combined with artificial intelligence in a process that will be automated and that will also read the data and try to optimize, for example, the control of a thermostat inside the building. And this way, we're able to deliver some services back to the building by leveraging ICT and all the way back to automated control to the building. That's in a nutshell our idea, and you'll see some more detail in my next slide. So now the services we envision for this virtual BMS is energy and comfort optimization, where we try to make a balance between reducing the energy use, but maximizing the comfort, or at least not compromising the existing comfort in a building while we reduce the energy use. The measurement and verification process, which is very useful to identify new retrofits and also quantify the savings of the existing ones. Demand response, fault detection and diagnosis, and predictive maintenance. These are our core services. And also we have additional ones, that is healthcare management for a care home for the elderly occupants, EV charging optimization, and car sharing application for a mobile phone. And of course, there is an opportunity to connect more services, also beyond the project scope. So now to enable this virtual BMS, we need some hardware components and some software components. So the key hardware components we need that need to be physically installed inside the building are the automation server, as you see on the left, which is used to connect to the existing and new building management system, or if there's not a building management system, we install it just to plug in there, like sensors and meters and smart thermostats that we use to control and optimize the heating and cooling, the demand response panel, and smart sensors or smart actuators that we need to enable to monitor and make predictions and enable the automated control. The key cloud software components now that we use is the enterprise server by Schneider Electric, which is used to connect to existing and new BMS sensors and meters. iScan software, which is used to store and analyze data collected from the building. A calibration tool by IES, which is used to enable predictions with a calibrated physics-based building energy model that will also sit on the cloud and make predictions alongside with machine learning algorithms, and API for third parties. So now looking at this diagram on the left box, you see is the building. On the right hand side are the cloud components, how all these components that you saw in the the two previous slides, how all these link together. The automation server is connected with a bilateral connection with the enterprise server. This hardware automation server is basically the link to all the hardware in the buildings, and also the link to the software components on the right, where we have iScan software for analyzing data. On top, there is a dashboard for the end user inside the building, or remotely. If the access is not possible, there will be a dashboard for let's say, for example, the facility manager, the office manager, and the occupant, and the physics-based 3D model. And again, there is a capability to connect any type of service here that is related, that can use prediction data, energy data from the building. So now during iBECOME, we're demonstrating those services and the virtual BMS in 4 buildings. On the left-hand side are smaller buildings with no BMS system, where we install the virtual BMS and try to make operational improvements to optimize energy and comfort. As you see, we have a country crest, which is a potato processing facility in Ireland. Helix building in Glasgow, UK, which is the IES headquarters. And on the right-hand side, we have 2 large buildings where we combine the virtual BMS with retrofits and existing BMS. So 4 different case studies in 4 different climates, and totally different use cases that our service will be tested. So now looking at in a bit more detail, the Helix building in Glasgow, which is in progress now. It's the headquarters of IS. It's an office building. It's considered small to medium office. There are like 90 people working there. So in this building, there are already some sensors installed, like measuring air quality, humidity, or CO2, and illuminants inside the building. We plan to install more. The building is controlled by 2-zone thermostats, so that's a bit inefficient. So we'll try to install more sensors, more thermostats, radiator valves for more detailed control of the heating, and deploy this virtual BMS in order to optimize. We'll try to automate heating control and optimize it based on comfort and also the electricity use. Provide suggestions and alerts from a dashboard to improve comfort and reduce as much as possible operational faults. And we'll try also to control the blinds on the windows and the window opening using comfort predictions. So now, very quickly, on the right-hand side, I added this table with the benefits of the European Green Deal, so that you see the connection of the key targets, the impact we expect the iBECOME project will bring. So we'll try to measure these figures on our demo sites based on the demonstration of the virtual BMS. So our target is to reduce the energy use and energy bills in a facility by 15%, reduce comfort complaints by 20%, and improve indoor air quality by 10%. To improve the smart readiness of buildings, the SRI, by 10%. Track, prevent, and reduce equipment and operational faults inside a building or facility by 20%. Improve wellness by 20%, and using our business models, innovative business models based on the EPC framework, will try to generate revenue by the energy savings to invest in further energy conservation measures. I think that's all from my side. Thank you for listening. And I would also invite you to stay tuned through our website and social media in iBECOME, because iBECOME is now entering year 3. So stay tuned to be informed about the demonstration of these services in our demo sites. And that's all from my side. Next presentation, we will hear from Georgia, from Rina, who's going to give you an overview of the Autodan project. Thank you.
So good morning to everyone. I'm Giorgia Spigliantini, and I work as a Research and Innovation Project Manager at Rina Consulting SPA in Italy. And today I'm going to present you the Autodan project, which is about deploying augmented intelligence solution in European buildings using data analytics and interoperable hardware-software architecture and a novel self-energy assessment methodology. The Autodan project was funded in the framework of Horizon 2020 program. It involves 12 partners from 4 different countries: Ireland, Italy, Spain, and Turkey. We have 6 demonstration sites in Ireland, a residential one, and let's say a tertiary buildings. Then in Italy, we have a residential building and a theater, a public building. And then we have 2 other similar residential buildings in Spain. We have 7 commercial partners ranging from small to medium enterprises and big enterprises like mine. And the project is coordinated by IES. And also we have 3 research partners like TU Dublin, Cardiff, and the University of Burgos. So as you have seen from the title, Autodan invests on the concept of augmented intelligence. So I think it's worth to spend a few words about this concept. So augmented intelligence is a design pattern for a human-centered partnership model between, let's say, the human intelligence and the artificial intelligence in order to work together and enhance the human capability of making decisions by implementing, let's say, some artificial intelligence. So in Autodan, we have 5 key objectives. The first is the creation of a flexible smart hardware infrastructure that can be applied to all small to medium-sized buildings. Then we would like to develop an interoperable software architecture that can provide all the analytical capabilities for assessing and self-optimizing buildings. Then, as I mentioned, we would like to deliver augmented intelligence solution in order to enable buildings and especially their users to become self-optimizing, so helping in making let's say, some decision for the energy operation of the building. And then we would like to create a live self-energy assessment method that incorporates operational monitoring, appliance system performance, and smart capabilities that will improve the accuracy of current energy assessment procedures. And finally, we would also like to accelerate investments by European companies, but also final users in order to optimize buildings' energy efficiency. So Autodan has quite a complex architecture, and in a minute I would try to explain, let's say, the different modules that compose this complex system, which is the Autodan platform. Basically, we have a smart hardware infrastructure, which is composed by several types of instruments for monitoring, but also partly to control some energy end users. Then we have a data analysis platform called iScan, which is able to, let's say, gather several data from calculation, but also monitoring. and to deliver some analytics. And this iScan is actually interoperable with a model, a digital twin of the buildings that we are going to target. The digital twin in itself is also composed by two modules, in which I will dig a little bit more in a few slides, which is also able to, let's say, establish an interface with the end user of the building, which could be, let's say, a normal user, so like a homeowner, but also a building manager of a small, medium-sized building. And then, as I mentioned, we have a self-energy assessment framework, which is the capability of our platform of delivering a continuous energy audit. And I will actually dig deeper into this theme in my next presentation this morning. So this is the kind of architecture of the Autodom platform, just represented with all these modules. And I will try now to get a little bit in detail about the different parts. So as I mentioned, we have a hardware infrastructure, which is composed by some smart metering infrastructure and some IoT equipment and smart appliances like smart TVs, smart refrigerators, etc., etc. So basically, we have some meters, energy meters for electricity, but not only electricity, also thermal energy, for example. Then we're going to have some smart appliances to analyze and also experiment in, let's say, in a comprehensive way with the other monitoring equipments, since we have a big white good producer in our consortium, Arcelic. Then we are going to have some smart plugs in order to somehow smartify some appliances which are not board smart somehow. And also we're planning to have a traffic light system in order to help the final users to take advantage of, for example, demand response capabilities. Then, as I mentioned, a big challenge that we have in the Autodom project is the creation of an interoperable software architecture, which includes several modules. So this representation might be a bit confused or difficult to be interpreted, so I will try with this one. So as I mentioned, in the left of the slide, you can see this smart hardware, so the appliances that we are going to put within our buildings for monitor and partially control some appliances. Then we will have a transversal platform called Sensiety, which is able to integrate all these different IoT solutions that we are going to have within the building. Because the big challenge here is to, let's say, make different type of products to speak together, let's say, properly, and also to gather all the data that are sensed by the building into a unique platform, gathering all the data, which is called iScan. And as I mentioned, within iScan, we're going to deliver several types of data analytics, including system fault detection and other types of machine learning algorithms. And these data are going to directly interact with a digital twin of the building. And the digital twin is in itself divided, let's say, in two levels. So we have a first level called the digital occupancy model, which is a digital twin, including the system and appliances and demand response of the building. So in this way, we will have very specific and tailored, let's say, analytics about the occupant behavior and habits in using the appliances of the buildings, and also identifying demand response opportunities. And then we are going to have also the second level, which is a more, I would say, traditional type of building and energy efficiency model, in which we are going to, let's say, be able to forecast some trends based on monitored data like climatic data, and also to, let's say, adjust, calibrate the model continuously based on the data that we are going to get from the building, in order to be able to provide very reliable forecasts about, for example, the uses, the energy uses, and the energy performance of the building. Then, as I mentioned, this, let's say, iBECOME platform is also able to interact and let's say, establish an interface with the end user of Autodan. And this is a very important part of the project, because we plan to have dashboards and also to deliver apps in order to be able to make the end user to understand the trends of their energy use in buildings, understand how they could change their habits and how they could take advantage of the opportunities for demand response, and also to be, let's say, helped in individualizing which interventions, like the substitution of some appliances, could impact the energy efficiency of their buildings. And quite a huge effort is also put into this activity in this project. We have a whole dedicated work package for the user friendliness of these interfaces. Then, as I mentioned, another module, let's say, of the Autodan architecture is the live energy assessment method, which is composed by, let's say, an engine, which is the self-energy performance assessment engine, which is able to deliver an Autodan live audit. So most often, as probably all of you know, we could perform an energy audit of buildings in order to understand how they perform really during the operational phase, because most normally during the design phase, we do some models and we expect the buildings to perform in some ways that are very often not the same that they perform in the real life. So somehow during the operational phase, let's say, we can do an energy audit in order to really understand how the building is used and which are the opportunities for ameliorate the energy performance of these buildings. But normally this operation is done, let's say, punctually in the time based on past trend. So it is not something that is adjusted or let's say updated based on monitored data. So our challenge here, and I will dig into this in my next presentation, is to deliver a system that is able to deliver an Autodan live audit, so that the change of behavior, change of habits of user of the buildings, for example, based on the suggestions that they will get from the dashboard, have really on the energy performance of the building. And also, as I previously mentioned, we have 6 demonstration sites. So as you can see on the left, you can see 2 residential buildings, one in Ireland, and these are very high-performing houses, and one in Italy, which is a little bit less performative buildings. Then we have a Palazzo Terragni, which is a public building, also cultural heritage building in Italy. Then we have the residential Camino de Santiago and in Spain, and Videburgos Foundation in Spain, which are the students' accommodations and residential buildings. And then finally, we have this Greenock and Aerodrome Business Park, in which we are aiming for demonstrating Autodan in more than one small to medium-sized tertiary building, so small production offices, etc. So we're now approaching month 20 of the project, and we would really like if you could stay engaged with our project, as we are going to deliver in just a few months the demonstration that we promised. So I really encourage you to get involved via the website and our social channels, like the LinkedIn page and also the Twitter page. And I thank you all and look forward for your question in the question and answer session. And also, I'm going now to introduce our energy policy officer, Eduardo Suarez Antunes from DG Ener, who will discuss the Green Deal policy.
Many thanks, Georgia. Also very interesting presentations so far. It's a pleasure to be here with you today. Today, I'm here to present to you an energy policy perspective, so especially in what concerns energy efficiency and research and innovation funding. As you know, both Autodan and iBECOME are projects supported under Horizon 2020 program, and I thought it could be interesting to talk a bit about the new framework for research and innovation fostered by the European Commission, which is called Horizon Europe, and understand a bit the policy context behind it. So Horizon Europe is the key funding program for research and innovation. It took over Horizon 2020, and it is structured for the period 2021-2027. The main priorities of this program are to tackle climate change, to help achieve the UN sustainable goals, and to boost competitiveness and growth in the European Union. The political priorities of the Commission that we're going to speak a little bit after this can only be implemented if we have a strong research and innovation capacity that can fuel the technological breakthroughs and make the policy desires happen. And in order to do so, we need financing. And this is why the new Horizon Europe program was reinforced in its financial capacity, and it is completely financed by the European Union's budget, which is called the Multi-Financial Framework. And for the total period of 21-27, we have almost 100 billion euros to be implemented for research and innovation. This includes all destinations of the Horizon Europe program. Although, as I told you, we will focus today mostly on the energy side and in specific energy efficiency. But to give you the context, the policy context behind research and innovation activities, we have to start with the overarching policy priority, which is the European Green Deal. This is a policy initiative by the Commission to turn the European Union into a green, robust, a modern, resource efficient, and competitive economy. This is, of course, a very ambitious plan, and it requires a transition, a green transition, to which it allies the digital transition that is also ongoing in the European Union. So where does the European Green Deal want to lead us? First, it wants to turn the European Union climate neutral by 2050. And in the route to do so, it will cut greenhouse gas emissions by at least 55% by 2030. So, and if you look at the graph here in my slides, this is all the areas that we need to touch upon in order to reach these goals. So how does this connect, so the European Green Deal, with research and innovation? And the words for this are mainly research, sustainability, and decarbonization. This means that we need to have a set of policies that are ready to mainstream those ideas, decarbonization and sustainability, and we need to mobilize research and innovation to make sure these objectives are complied with as well. So in a nutshell, the idea that I want to pass to you, that policy developments from our side and research and innovation financing need to go hand in hand so that all the package goes into the same direction. Additionally, it's important to say that all this transition that is preconized by the European Green Deal cannot be done, or must be done actually, in a just way. So with the concept of inclusivity and affordability, so that no one can be left behind. So having the general policy priority and is a background, now we start to think how we're going to implement it. And this leads us, on one energy policy is concerned, to the Fit for 55 package. This is an initiative to deliver the European Green Deal. But as I said, this has to be done in some structured way. And this means to be done in a fair, cost-efficient, and competitive way. The Fit for 55 is one of the most comprehensive legislative packages in the fight against climate change. It's, if you want, it's a sort of legislative arm of the European Green Deal. It foresees, sets out the important changes in European legislation, to which I would like to mostly focus on three, which are the revision of the Renewable Energy Directive, the revision of the Energy Efficiency Directive, and the revision of the Energy Performance of Buildings Directive. So we're going to have a close look at these three proposals from the Commission, but having in mind that these are, we are analyzing proposals from the Commission, so the legislative procedure is well underway, but also the Parliament and the Council now have to carry on the work, legislative work on these proposals, which of course can mean that some changes can be introduced in legislative procedure. So if we move to the revision of the Renewable Energy Directive, the main features of this proposal are the following. It's increased renewable energy sources ambition in key areas, such as heating and cooling, transport, industry, and buildings. The idea is to boost the deployment and investment in renewable energies. And for this, it sets a new binding European Union target for 2030 for renewable energy sources in the energy mix. So the idea is to increase from the previous 32% ambition in the level of renewable energies to a new 40% presence of renewable energies ambition in the energy mix of the European Union. If we move to the second proposal that I wanted to point out to you, which is the revision of the Energy Efficiency Directive, the first feature that I'd like to point out is the fact that it reinforces the already existent energy efficiency first principle. This principle means that in any investment, any policy to be taken, energy efficiency must be considered and calculated in beforehand, so that the investment or the policy or the action also from public authorities can have the energy efficiency mindset as a background. It also this new proposal also contains measures to alleviate energy poverty and boost consumer empowerment, so that demand products and services, so that citizens can demand products and services which are more energy efficient, and like this increase the energy efficiency in our daily life. Just like in the previous proposal of the Renewable Energies Directive, the Energy Efficiency Directive also sets new ambitions for the energy efficiency targets for 2030. So as you can see, we are talking about an increase from the previous 32.5 EU non-binding target to a new EU binding target for 2030 for final and primary energy consumption, respectively, of 36 to 39%. The last proposal included in the Fit for 55 package that I would like to share with you is the revision of the energy performance of buildings directives. And this includes a group of measures that go very well into the need to renovate the building stock in the European Union. So the first example of this is the existence of the union-wide minimum energy performance standards, which are usually called MAPs. The idea is to create these standards to force the phasing out of worst performance buildings in member states as of 2027. This includes public and non-residential buildings, and as of 2030 for residential buildings, so that successively we have the worst performing buildings being renovated and thus increasing the level of sustainability and efficiency of our building stock. But also for new buildings, it's important to establish rules, and that's why there's an ambition to create zero emission buildings. These are buildings that new buildings from 2027 should be carbon neutral. And of course, 2027 is the date for public buildings and 2030 for the remaining buildings. But also financing is important and was taken into consideration in the revision of the EPBD, the Energy Performance of Buildings Directive. And this is why there is an encouragement of innovating financing. So this includes the rollout of enabling funding and financial tools, such as energy efficiency loans and mortgages for building renovation, fiscal incentives that can be given for this for deep renovations, and creation of funds that can target the same renovations. Finally, there is a revision of the existing system of energy performance certificates, which also consider the need to have a wider access to the information that exists currently in DPCs. So all these three examples of directives revision proposals that are in Fit for 55 have a clear link with the research and innovation activities that we saw under Horizon 2020 and that we'll see under Horizon Europe now. We're developing techniques for construction, for building renovation, and for the use of materials or recycling of materials that will contribute for a more sustainable and decarbonized building stock of the future, which will then correspond to the MAPs and ZEBs standards that we've just talked with you about. But while speaking about the PBD, the Energy Performance of Building Directive, it's not possible to move on without having a look at the European strategy called Renovation Wave. This is indeed a strategy to boost buildings renovations in Europe, and it focuses on three main areas. Those are tackling energy poverty and the worst performing buildings, the renovation of public buildings, including social housing, and also the decarbonization of heating and cooling. The main objective is to double the current renovation rates in the next 10 years so that it can foster deep renovations. This would create, we have an estimation of 160,000 jobs in the construction sector. And also, hopefully, we can deliver 35 million building renovations by 2030. This is the main policy priorities from DG Energy, which would be the guiding principles for research and innovation activities that you'll find in Horizon Europe in the energy sector. But there are still a couple of policies that I'd like to share with you that will also influence, that I would say that were not present by the time that Horizon Europe, the new program, was created, but that arose now and for sure will have an impact in the activities to come. The first of which is the new European Bauhaus. This is an initiative from the Commission that connects the Green Deal to living spaces and experiences. This is not an energy only an energy related policy. It is rather an interdisciplinary movement to make the green transition a tangible experience for people. And it is important that also in the destinations for research and innovation that relate to energy, we retain this people-centric approach so that in case of building renovations, we remember ourselves that whatever developments we are fostering, they need to be to make the building and the living spaces more comfortable for the people who use it. So the new European Bauhaus is built upon 3 pillars. The first of which is sustainability, which includes the concept of circularity. The second of which aesthetics, and aesthetics is not only about buildings being or architecture being beautiful, but also that they encompass good quality of life and well-being of the people. And finally, inclusivity, including the accessibility and affordability, which of course plays very well with the objective of the Green Deal of not leaving anyone behind with the green transition. It is impossible to implement building renovation and implement the objectives of the renovation wave that we've just talked about without having intersections with the pillars of the new European Bauhaus. And this is why you should expect to see references to the new European Bauhaus also in the energy destinations of the new research and innovation activities under Horizon Europe program. The other policy priority that I would like to talk about, because it's impossible at the current stage not to refer to it, is the new communication of the Commission called Repower EU. This is, of course, a consequence of the energy shortcomings that happened due to the aggression of Russia against Ukraine. And the Commission presented this roadmap for accelerated actions to tackle this problem, which focus on 3 main objectives. The first of which is to address immediate needs, to mitigate high retail prices and ensure sufficient gas storage at one place. But the second, and the one that I would like to focus more about, is to reduce the EU's dependencies, meaning the eliminate dependency of the European Union to Russian fossil fuels. And to do so, we need actually to focus and implement the European Green Deal and the Fit for 55. This means boosting renewable energy deployment and energy efficiency projects. As I told you, while it was not there when the Horizon Europe facility was created, this communication turns all the energy priorities that I mentioned to you beforehand very much an imperative, because the green transition and decarbonization is the only way that we can move forward to reduce our external dependencies. Actually, also, the Repower EU has a specific track called Electrify Europe, which, for instance, in what houses and buildings are concerned, sets out the electrification of building thermic needs with a very specific impetus on the deployment of heat pumps. Also, together with Repower EU communication, there was Repower EU Safe Energy communication, which goes together hand in hand with the previous one. And the idea is it has a dual approach. The first one is to, of course, to reduce as soon as possible the energy consumption in Europe by behavioral change. But the second one, it means that we need to accelerate and strengthen structural energy measures. So this goes to what I say, that all the policy that we have discussed now will be more and more important. This creates momentum for the policy developments that we have discussed, and of course strongly relates with energy efficiency in buildings, which in the end the projects that we are discussing here today, so both iBECOME and Autodan, will contribute. So hopefully will contribute to have a decarbonized and more efficient building stock, which will contribute to all the goals that we have discussed. So this was a short summary that I wanted to present to you of the main political priorities around energy efficiency, very close with energy efficiency in buildings, and of course that set the tone for the research and innovation environment that we will be experiencing in the European Union in the coming years. It was a pleasure to share this with you, and I now pass the floor to Simone Buffa from CVESCO, who will speak about the exploitation strategies of both iBECOME and Autodan projects. Thank you so much.
Thank you, Mr. Antunes. Good morning, everybody. My name is Simone Buffa, and I'm an energy engineer and a project manager for CVESCO, responsible for both Autodan and iBECOME projects and for their demonstration in two pilots. Today, I will show you somehow a brief overview of the exploitation strategies and replication potential of the cutting-edge technologies that we are developing in these projects. I divided my speech into 4 parts. So first of all, I will introduce you to the concept of exploitation. Then I will show you some activities we are performing as exploitation strategies. And then I will move to the replication potential and some take-home messages for you. Okay, so let's get started. So first of all, for Horizon 2020, Horizon Europe projects, and in general for research projects, it will be it's very important to understand the difference between two important activities: dissemination and exploitation. So on one hand, dissemination aims at making results available, usually for the general public, for different purposes. On the other hand, we have exploitation that actually focus more on making the use of those results that are more somehow are activities more connected to business, I would say, since they can push forward the creation of new companies, startups, as well as the asking permission for new patents, or I would say defining other activities for protecting the results through different options for licensing. And if we consider somehow the results that usually are created in this project, I would like to use this example somehow to show you the tool that we usually apply in both Autodan and iBECOME, that is the exploitation plan. Actually, this is a deliverable and includes a series of activities with the aims at implementing the path to impact. So on one end, we have the exploitable results that can be a product or a service, or some innovation that is developed in the project. And there are different steps that usually it's important to follow. So on one end, it's important to understand which problems this product aims at solving. On the other hand, if there is a collaboration, it's important to define the ownership. So who is the owner of this know-how created, and on the other hand, how they would like, a partner would like, for instance, to protect this know-how. Then it's also important to understand the business model for somehow bringing this product to the market and the application potential. And somehow there are other exploitation activities that I will describe you in a few minutes that somehow support the impact of what project results can maximize. So differently from this example of a spaceport where somehow the impact should be minimized, in our project we have to consider it on the contrary. So we have to maximize the impact, so the long-term effect that what somehow the value created can have on the society. Good. Now let's move to some description of the exploitation activities that we perform. So usually we follow these main steps. So we describe the results through characterization tables. A pattern analysis usually is also performed together with a description of the state of the art. And what is also important is to collect the feedback from the partners, and they somehow understand very clearly their interaction and the creation of know-how. So now I will describe you briefly what a characterization usually includes. For sure, it's important to describe the problem that is somehow that arise somehow that the project somehow aims at solving in the details with this new result and this new technology. If there is also an identification of alternative solution already available in the market. And then what is important, I would say, is what is called unique selling point, that somehow try to identify on one hand somehow the aspect connected to the value proposition. So what actually make this product, this result different from the others available in the market, and trying to match this with the customer needs somehow and customer somehow activities. And then for sure it's important to describe in the details the product and to understand the route to market. So on one hand, to understand the target market, which could be early adopters and also competitors that you can have. And on the other hand, it's important to identify the business models and the intellectual property rights protection. And to help our partners in this activity, RINA-C developed a characterization checklist in Autodan that somehow support non-expert, I would say, in defining this characterization table. Okay, now I will show you quickly some exploitable results. So some innovative technologies that we are developing in this project. Some of them, I will start from Autodan. So on here we have a list of products actually developed in the project. There are tools for the integration of different source of data, metering sensor that are innovative and actually that allow to have a more detailed understanding of the measurements. Tools or a service that actually helps the user to evaluate the energy assessment, so the energy efficiency of its own building. And then here there are other tools for somehow detecting occupancy in buildings, and a dashboard, for instance, to support the interaction between the algorithms and the user behavior. And finally, there is also a service for demand response at community level. So these are the main results identified so far for Autodom that will be demonstrated to the project. If we now look in iBECOME, the list is bigger, since iBECOME for some aspect is a bit more complicated and involve a different range of services. So on one end, there are software and algorithms that aims at improving the comfort and the fault detection of buildings. Also the exploitation of digital twins for developing renovation what-if scenarios. Application of demand response, but also we are going to develop apps for car sharing and a software for optimization charging or of e-vehicles. Another important service will be the connection between building monitoring and people well-being, so care management. But then there are also other technical tools that would be used to actually implement those services into our demo case. And finally, last but not least, we especially we in CVSCO are responsible for the activities concerning the legislative aspects for the implementation of this complex solution and for financing them through APC contract on one end, and also to identify the collaborative framework for all these stakeholders involved. Good. So now I will show you some results of a pattern analysis that has been performed, just to give you some insight on detailed activities performed in Autodom. So these are some results performed by Rina during the, to support somehow the exploitation of this smart electricity sensor developed by the partner mSemicon. And as you can see, here we have this chart that show the trend in publishing for smart IoT metering worldwide. And we can see from that from 2011 and up to 2020, about 9,000 patents have been registered, with a trend that was always growing somehow apart between 2010 and 2019. But what is somehow really important to highlight is this big step between 2019 and 2020. And this somehow help us in understand that the technology now is quite mature and ready to be commercialized. If we look at the top aspects, so who actually is the owner of those patents? Here there is this bar chart that actually identify that the main corporation comes from China, USA, and Japan. So there are few, I would say, big European companies that own those patents. And if we consider the classification of those patents, so the key areas of research, again, we have another bar charts here with this legend and these codes that identified the areas of research. And if we consider only the first three, somehow they focus mainly on metering system for remote indication of the network condition, as well as the remote control of switching of those networks. Then we have somehow metering system for electricity, gas, or water supply. So this is more general, I would say, as a classification. And finally, there is somehow a trend for meters that allow transmitting signals through wireless electrical link. And finally, to conclude this study, I would like to highlight that if we consider the geographic coverage of those patents, again, we have in the top list China and USA and Japan. The main somehow patents cover those countries. Only 10% are somehow developed worldwide, and only 7.6% actually are patent claim in European countries at the European Patent Office. Okay, so now we'll move quickly on the replication potential of the technologies somehow developed in both Autodan and iBECOME. Now I will show you another results of our studies that comes from the deliverable 6.1 again by Rina that will be published soon. So, and will be available for everybody. So here what I would like to show you is a projection of the smart building market. Actually there was this interesting study that has been done that somehow here aggregate both hardware and software components for different application, but both somehow all connected to smart buildings. And if we look to these bar charts that we have on the right hand side, we can see that there is a very clear trend. The market share somehow for 2020 reached about $60 billion. And there is a trend somehow with an annual compound growth rate of about 19.4%, and it's expected that this market will reach about $165 billion by 2025. And if we look at the different players in this market, the main somehow share are between United States in dark blue, Western Europe in light blue, and then we have China in light red. So those are the main growing market for smart buildings technologies, and the main drivers that has been identified are the need for more comfortable and safer environments, especially after the pandemic. The growing number of smart city projects. So somehow you don't, it's difficult to achieve to have smart cities if you don't have smart buildings. The growing urbanization trends, usually in Asia, and also the growing demand for energy efficiency and environmental friendly solution. So now I will go to giving you some messages. So in this kind of research projects, is for sure very important to exploit the results to increase the impact of the project and the value created. I suggest somehow also to have a committee, as we have in Autodan, that can somehow help in defining these strategies and all the aspects that are related to the intellectual property rights creation. Another activities important and useful that we are going to perform is a BF-MUR analysis that somehow allow to limit disputes and allowed to identify for all the partners somehow the different exploitation claims and expectation after the end of the project. And finally, I would like to stress that, I mean, as I show you in the last slide, there is a growing trend in the smart building market and smart technologies for making buildings more efficiency. but also it's important that policymakers and companies somehow support industry and the supply chain in this segment as a follow-up somehow of the CHIPS Act, that has been approved by the European Commission. This because Europe seems that is an important growing market in this technology, but again in this sector. But again, the problem that could arise is that we can increase the energy efficiency of our building stock using products and somehow and supporting supply chains that comes from other continents. And that was all from my side. Thank you for listening to me. And now I will give the floor again to Georgia. That we'll have a second presentation of today, and I will show you the contribution of Autodan, the Autodan policy contribution to the European Green Deal. So Georgia, the floor is yours.
Thank you, Simone. Okay, so good morning again. And in this second presentation, as Simone mentioned, I'm going to guide you through the path that the Autodan project did in order to contribute to the European Green Deal. So in Autodan, we actually have a dedicated activity for the review of the European regulatory framework concerning the energy performance of buildings directives and also the eco-design directives. And these activities is in the framework of a work package which is dedicated to the creation of the self-energy assessment methodology, which is developed within the project. So in particular, within the project, this new methodology is going to be created in order to incorporate the performance of a building, including, let's say, different layers that normally are accounted separately. And namely, we're going to put together, let's say, the perspective of the building level, the product level, like the white goods level, and also the financial level. By integrating in-use monitoring and also addressing the calculation of the smart readiness indicator, and also a demand response capability of buildings. So this is kind of the regulatory framework that we adopted in order to do this first review activity. And as you can see, there are, let's say, two binaries and one transversal activity. So on the one hand, we analyzed all those directives that are related to the building level energy performance, together with their overarching standards. And also we had a focus on the smart readiness indicator, let's say, directive, but also regulation, because we really wanted to include this dimension on our framework as well. And parallelly, thanks to the help of a partner who is, let's say, an expert about white goods, since he produces this kind of products, Arcelic, we had the possibility to focus also on the eco-design and energy labeling of products such as dishwashers, ovens, smart TVs, etc. And third, as I mentioned, we have also a transversal activity which is performed by CVESCO in order to understand, let's say, the integration of these two dimensions into financially viable, let's say, schemes. So contributing to create, let's say, some solutions that could be really implementable by final users of small to medium buildings. So I will not repeat, let's say, the explanation about the energy performance of buildings directive. Just to mention that we addressed, let's say, all the different releases that were available during these 20 years. And also we had a look to the most recent proposal for revision of the European Performance of Building Directive. And as I mentioned, we also, let's say, analyzed the more implementative standards of these standards in order to come up with, let's say, operative solutions for our methodology. So we addressed also the very last proposal of revision of the EPBD, and particularly I would like to stress, let's say, how our self-energy assessment methodology is going to contribute also to this brand new, let's say, perspective of the proposal of the EPBD. So with our project in general, but more specifically with this methodology, we're addressing the reliability, quality, and digitalization of buildings, and also of energy performance certificates. And also we are addressing the system integration, including heating, cooling, ventilation, but in our case also the dimension of the products. And also we are addressing the smart readiness indicator, so the smartness of buildings. So we are implementing the energy performance monitoring, and in order to increase the energy performance of buildings, and as I stressed in the previous methodology, Autodan is, let's say, very human-centered. So there is a huge effort within the project to try to deliver user-friendly interfaces and solutions in general. So the parallel binary, as I mentioned, is the product layer, let's say. So we had a look to the eco-design directives. The eco-design directives set common European-wide minimum standards in order to progressively remove the least performing products, so like white goods, and in order to, let's say, make some barriers for those products that are not energy efficient enough. So basically, this is kind of a barrier that is performed before these white goods enter the market. So the final user actually sees the energy label of the products, which is kind of a clear indication about the energy efficiency of the different appliances that are in the market, so which are already compliant with the eco-design, but within the compliant, let's say, products, the final users have the possibility to choose the most performing one, let's say. So from these eco-design directives, we had the necessity to extract some indicators, some assessment methodology to be integrated in our methodology in order to deliver a comprehensive assessment of the building and the building products all together. So we actually could see that most eco-design, but also eco-labeling procedures are based on the calculation of an energy efficiency index, which is actually appliance specific. So each appliance has its own, let's say, calculation method, and also different methods for the labeling. So it's quite a complex framework, but the important part is that actually we could individualize some aspects that could be proficiently integrated within our methodology. And the third layer, as I mentioned, concern the financing of sustainable energy, because smart buildings and the solutions that we would like to deliver within Autodan, it's something that is related to the performance of the building during the operational phase. So once the building is already built, and maybe it is not performing as it was expected to perform, we have a rebound effect. It's called like this. So there is a gap between the expected energy performance of the building from the design phase and how the building really performs in a real environment, let's say. So it is very important to understand how to account for these rebound effects. And we could say that this self-energy assessment methodology is aimed at, let's say, providing a clear picture about why the building is not performing as it was expected. But at the same time, once some energy efficiency opportunities are individualized, it is important to individualize also some viable mechanisms for financing these interventions, which could be smaller or bigger, but still very often they demand the contribution of some financial help from various, let's say, sources. So during this activity, we also accounted for this third dimension. So on an operational level, what we did was to try to integrate these three layers all together, and we started to brainstorm between the partners involved in the activity in order to really have these three layers all together in our calculation. And so for the self-energy assessment methodology, we started by this framework, which represents, let's say, the energy that is going to be needed by the building. You can see it in the upper part of the slide, the delivered energy to the building. So how much energy do I need in order to cover these needs that I have? And also the overall energy performance, which includes also, let's say, the environmental impact of the building. And this framework is actually coming from one of the overarching standards of the European Performance of Building Directive, so the APBD. So basically, in the upper part, we have the net energy, so the energy that is needed from the building, and it's also an input for our methodology. So we will have some of these variables monitored in the different sites, and some others will be made as assumptions, as we normally do, let's say, for the energy models. And the digital twin will use the same inputs as the self-energy assessment, which is kind of a calculation based on monitored data, basically. Then we will have the monitoring system concerning the delivered energy in order to collect information from the equipment. And here the efficiency of each energy use will be calculated. And the novelty, let's say, of our approach is that the appliances, which are normally in this kind of calculation accounted all together, aggregated and based on some basic assumption about, for example, the performance of these appliances, but also the habits of use by the different user. In this methodology will actually be accounted based on monitoring of some of these relevant appliances, and they will be also introduced in the calculation of the overall energy performances in a detailed way. So at the building level, we will have some KPIs related to, let's say, the energy need, the envelope performance of the building, which normally help to identify some energy efficiency measures that could be implemented in order to, let's say, enhance the energy performance of the building. And this kind of KPI will be based on actual climatic condition, where we will have the possibility to monitor some outdoor variables, for example. Then at the end of the calculation, we will have two kinds of energy, of primary energy and energy performance. One more traditional, let's say, based on the overarching standards of a PVD, so without the appliance contribution, or actually with a simplified appliance contribution, and a new one, which includes the appliances, as I mentioned, based on our very specific calculation method, which is able to account for the real contribution of the appliances within the building energy performance. Then, as I mentioned, we also thought that it was very important to integrate the smartness of building and the building automation capability within buildings. So we are going to deliver a method that is able also to take into account the smart readiness of buildings and their demand response capabilities as well. So in the end, this is kind of the overall picture which represents the three layers that I showed you and their translation into the calculation of the self-energy assessment, which will be, let's say, peculiar also because several of these KPIs will be calculated over time, so they will be actually able to account for the behavioral change of users or change of needs of them. So as I mentioned, we will have some building level performance indicators, some appliance level performance indicators. And concerning the smart readiness of buildings, so for those who are expert on these aspects, they know that this is kind of, it's not a kind of dynamic indicator because it's based on the technological infrastructure of the building. So what we will do also in order to support the implementation of the energy efficiency action, we will provide a gamification scheme where the users will be able to see the impact of changing some elements of their system, like some appliances, the dishwasher, the washing machine, whatever, and see what would be the potential impact on the smartness of the building, but also in energy and financial terms. So next things to do will be to let's say, actually translate this methodology on algorithms, and this is an ongoing activity. So I recommend you to stay in touch with us in order to see what will be the next steps. Thank you very much. This is all from my side. And now I will introduce Pierre from CEA, who will talk us through iBECOME's policy contribution to the European Green Deal.
Yes, many thanks, Georgia. Good morning, everyone. Thanks for joining this webinar. My name is Pierre Bernot. I work for CEA. CEA is a French research and technology organization. And my contribution today is to present you in a few minutes the iBECOME policy contribution to the European Union Green Deal. So first of all, I will describe you shortly what is the iBECOME software solution as a software. Also, I will present you the regulatory framework of iBECOME. And then I will try to highlight the relation between the European codes and standards and the solutions that we are currently developing with partners within iBECOME project. So first of all, iBECOME solution, as already presented by Dimitrios, we are currently aiming to develop and deploy advanced BMS features. So building management system is currently installed on existing and new buildings here, as you can see here. And within iBECOME project, we are currently working to develop iBECOME services, innovative services that you can see here on this picture. These innovative services can be separated in two categories. Services some of these services are dedicated to diagnosis and analysis, such as predictive maintenance, fault detection and diagnosis for the building, also measurement and verification, and what-if scenarios. I will present you them more in detail later on this presentation. And we are currently also developing services for control, for HVAC system control inside the building. So, for example, predictive control. And also regarding the grid, we are also working on demand response services that will be integrated in the iBECOME solution. Considering the regulatory framework, you can see here on this diagram that iBECOME regulatory framework is transcending two main domains that are energy management in buildings and data management. Data management is mainly addressed through the building management system, the BMS. iBECOME solution is dealing with several key activities, such as ICT standards, so information and communication technologies. Also with energy service companies that can be provided on the building, aggregators in charge of demand response services, and also iBECOME regulatory framework is also dealing with data privacy and security. So now regarding the European legislation context, so we have now quite a clear vision of the different European directives, but let me show you what we are considering within iBECOME project. So European member states are required to develop national energy and climate plans and ECP and long-term strategy, LTS, by the governance regulation in order to drive the specification of the new buildings and the existing buildings. And the objective is to reach the decarbonization of the European Union. So these objectives are declined and set by the Energy Performance and of Building Directive, the EPBD, the Energy Efficiency Directive, the EED, and the Renewable Energy Directive, the RED. For each one of these directives, I will now try to highlight and to show you how iBECOME solution is trying to contribute to this objective, and how iBECOME solution is trying to have an impact on this objective. So first of all, iBECOME contribution to the EPPD. You can see here one of the main objectives of the EPPD. Every new building must be a near zero energy building in 2030. EPBD implies also a long-term strategy in terms of renovation that can be conducted through energy conservation measures. And in terms of impact on the building sector, the EPBD implies that the BMS will optimize energy performance calculation method in order to better estimate energy performance requirements. During this analysis regarding the European legislation context, we have conducted also several interviews to estimate and to have a more clear vision of what are the expected impacts on the legislation. So, for example, building automation technologies based on feedback from European Building Automation and Control Association, UBAC. Building automation technologies are bridging the gap between the calculations estimated and what actually can be achieved by the building. So to illustrate now the impact on this objective of the iBECOME solution, you can see here on this picture one of the services that we are currently developing and deploying on the demonstrators presented by on the building demonstrators presented by Dimitrios previously. So coupling measure and verification platform with the existing BMS could simplify and optimize the calculation of real energy performance by dealing in real time with all data coming from the building. So this is one of the objectives addressed by the iBECOME virtual BMS. So as you can see here, we have a baseline period. Here we are deploying energy conservation measures on the building, and by the help of the iBECOME virtual BMS, we are able to estimate the savings brought by these energy conservation measures by making the difference between the adjusted baseline here in black and the real new consumption, the real new energy performance of the building. So this measurement and verification service is already integrated in the iBECOME solution. Also, a PBD implies that energy performance certificates need periodical technical inspection of HVAC systems. So this is one of the main challenge of the next coming years. So also in iBECOME, the virtual BMS aims to reduce the frequency of inspection and facilitate the maintenance operations through two kinds of services. The first one is fault detection and diagnosis, and the second one is predictive maintenance service. So it is illustrated by the pictures that you can see here. So we are working, for example, on one heat pump here, which is producing cool or hot water depending on the season. And what we are trying to do is to build a model of this heat pump in order to be able to anticipate and to detect defaults that are coming for the performance and that are impacting the performance of the heat pump in order to prevent extra energy consumption for this system. Considering the iBECOME contribution to the energy efficiency directive, so one of the main objectives of this directive is to reduce to 55% the greenhouse gas emission compared to 1990. In 2030, 32.5% of the energy efficiency compared to a business as usual scenario, projecting the energy use for 2030. So considering these two main objectives, iBECOME solution is trying to reduce CO2 impact of energy consumed by the building, and also to improve the energy efficiency of the building where the solution is deployed through two kinds of services. The first one is predictive control, and the second one is demand response service regarding regarding the behavior of the grid, depending of the energy production coming from the grid. So you can see here on this picture that we are trying to control the HVAC system of the building, considering the energy price or the energy, the CO2 level of the energy production. And based on this information, we are trying to anticipate the control of the systems in order to maintain the thermal comfort of the occupants of the building within a good range of temperature. last but not least, one of the iBECOME contribution for the European legislation is to have an impact on renewable energy integration on the building. So as you may know, already RED directive implies a 2030 EU renewable energy target in buildings of 32%. And it also implies that member states should aim to increase the share of renewable energy in heating and cooling production by 1.3% per year between 2020 and 2030. So one of the important part of iBECOME solution is to try to help stakeholders to evaluate the potential of integration of renewable energy sources through what we call what-if scenarios. So it is illustrated here on this picture. As you can see, this is the digital twin of one of our demo sites based in Italy. And using the iBECOME solution and the digital twin of the building integrated in the iBECOME software, we can use this tool to evaluate the impact of PV panels deployment on this building, which is not currently which are not currently installed on the building. So to evaluate the potential and to see if it's relevant, considering financial criteria or considering energy production criteria to take the decision. So as you can see here, what if scenario can help stakeholders, can help tenants, and can help also a facility manager to take decision regarding the energy efficiency of their own building. Okay, so just to conclude this presentation, and as I hope that you have understood, iBECOME Consortium aims to develop, deploy, and validate software as a solution with a high added value level for existing BMS, building management system, in close relation with the European codes and standard as presented previously, and also with the national rules declined by member states of European Union. So thank you all, and I give you now the floor back to Mark, who will lead the question and answer session.
Thanks, Pierre. Thanks everyone for the presentations. So yeah, we're just coming towards the end of the workshop now. I think there's just time for maybe one or two questions. So I think first, just looking through my questions here, we have time for, I think, Eduardo, if you're still on the line, we'll just have a question for you, which is regarding I suppose it's a question aimed for two projects. Would you see projects like Autodan and iBECOME to be well suited in the new Horizon framework and the new identified policy developments?
Yes, thank you, Mark. Yeah, absolutely, totally. I think projects like we just saw today, they are very much in line with all the policy priorities that I had the possibility to discuss with you in the area of research and innovation activities. In what concerns energy efficiency, we still see many areas for improvement and for technological change and improvement. For instance, we need to enhance circularity and sustainability of materials. Also, we need to make our building stock more resilient for altered conditions and still to improve the adaptability and extend the life cycle of buildings. We need also more solutions for waste management and increased reuse and recycling of building elements. And I would say, in what more Autodan and iBECOME is concerned, new digital solutions are needed to better dynamically manage energy, in the sense that digitalization, data on buildings, energy use, and smart building solutions will have a significant role in achieving what we want to, all the priorities that we have, which is in the end a more sustainable and decarbonized building stock.
Thanks, Eduardo. I know you've a busy day, so thanks for making some time out to feature on our workshop today. And if you have to go now, that's okay, because I know you're a busy
lot,
man.
Pierre.
So thank you.
I really have to go now, but it was a pleasure to be here with you, and good luck for the rest of your presentation and the programs. Thank you.
Thanks, Eduardo. So yeah, I think maybe we could just have time for one or two extra questions. So Georgia, sorry to ask you to come online for the third time today. So just to look at your second presentation on the policy contribution, can you provide some further detail about the gamification scheme that you intend to propose?
Yes, of course. Well, let's see, in the framework of what Eduardo told us during the very interesting presentation about the Green Deal and the other initiatives at the European level, we really need to boost the energy retrofit and the renovation of buildings. So it is very important for the Autodom project, but more generally, to help final users in order to understand how to address the energy performance of their buildings, and in some cases that they do not have the possibility maybe to make a deep renovation of their building, but they could still evaluate, for example, to change some appliances like the dishwasher or the washing machine or whatever. So the system is going to allow the final user to see the impact of some of these changes on the overall energy performance of their buildings. So this way they can really evaluate what are firstly the worst performing appliances, for example, so where to start with some intervention, even small ones, and what would be the impact on the overall energy performance. So that's the kind of gamification that we're going to have, and we're going to link this kind of gamification with the concept of smartness and particularly the smart readiness indicator, because sometimes let's say final users like house owners think that the smart building is, let's say, a fancy building in which they can automatically switch on and off lights and things like this. It is that, of course, but it's also something more, something that could really impact their daily lives, their lifestyles, and actually also their financial, let's say, state by impacting the energy bills.
Great answer. Thanks, Georgia. So yeah, I think maybe for the last question for today, as the workshop was centered around policy, and Pierre, if we could just have, I think there's one question that came in for you. Just can you provide more detail about interviews that have been conducted to complete the analysis on European legislation and directives, please?
Yes, of course. So as mentioned, we have conducted several interviews in order to better understand the impact and what does imply in terms of services for the building management system. So we have conducted interviews to we have interviewed members of European association that are playing a role in energy and digital transition in buildings. So, for example, we have a interesting and discussion with SmartEN, which is a European business association integrating the consumer-driven solution of the clean energy transition. With Michel Villa, which is the executive director of SmartEN. Also with Smart Building Alliance, which is a European association supporting all players in the building and city sector in the digital transition and energy transition. And also with iBECOME, iBECOME is a European Building Automation and Control Association based in Brussels, which bring together professionals from the building control and the regulation sector. So we collect feedback from them regarding the different European directives that I've presented, and it was a really interesting impact on our analysis to identify the main outcomes from the legislation. Yeah.
Thanks very much, Pierre. Yeah, so I think there's only a couple of minutes left. I think it's okay if we finish up and give people some couple of minutes back to their day. I'd like to thank everybody for attending our workshop today, to the speakers who put so much time into their preparation and delivered such interesting presentations. As we mentioned throughout the workshop, please visit the iBECOME and Autodan websites or social media channels to keep up to date with the progress of both projects. And also, as I mentioned at the beginning, please check out the EU Green Week website to check the other events that are taking place, whether online or in certain areas around Europe this week. So thanks everybody, and we'll hopefully see you at another workshop soon. Thank you.
Thank you, Mark, and everyone.
Thank you.
Thank you. Bye.
Bye-bye.